So of course now we're gonna have to do real world problems. So here I'm setting up A because I've looked ahead a little bit. But high school students in Palo Alto, California, can buy ticket booklets. These are for lunch, and they're shown in the graph. And so if I look at the x-axis, looks like that's going to be the meals that are purchased, while the y-axis is going to be the value of the booklets. So it seems like after 0 meals have been eaten, the cost of the booklet is 60. So I assume that's the initial price. And the more and more you eat, you eventually run out of meal tickets, and so the booklet has no value to you anymore. And so if we're talking about the x-intercept, I'm going to set it up by putting x-int and then a colon. And there's really no math to be done here. So I'll do the same thing for the y-intercept. And then lastly, for the 0. So I'm just setting this up and labeling them. So that we set this up, well, what you remember is, with the x and the y-intercepts, we can set up coordinates, and we know that there's a value that's 0. So let's pretend you didn't remember this from the most recent video. So you're like, well, the x-intercept, I do remember that my teacher said that's where it runs into the x-axis. So here my line is going from the left to right, and there's where it hits the x-axis. And it's like, well, it looks like there's a value of x there, but if I had to figure out what the 0 value would be, well, that would be y, because there's no elevation to that at all. There's no height. So at the x-intercept, that's where y is 0. And if you're certain of that, then you'd be like, well, at the y-intercept, that's where x is 0. But if you weren't, you could maybe walk backwards and be like, well, here's where x is nothing, and that's how we do it. X-intercept. Looks very clear to me. This graph is definitely at 20. So my x-intercept is 20, 0. On the other side of it, it's definitely 60 there, so I got 0, 60. So all I'm doing is I'm pulling out the x and y-intercept. And so one thing we haven't talked as much about is the 0. If I had a function that looked like this would be a 0, that would be a 0. We're interested in the height. You'll have functions that, look like waves. And these will have multiple zeros. It's possible. It's pretty cool, actually. It's called the sinusoidal function. And so when I'm looking at the 0, that's where the value of y is 0. So this would be x equals 20. Since that's a somewhat new idea, go ahead and label that as the 0 on this initial graph. Then we're asked to describe what the intercepts mean. And so as I describe what the intercepts mean, since x is earlier in the alphabet, be like the x-intercept is when the booklet has no value. Meaning no worth. It does have a value, its value is 0. And then the y-intercept was when the book was, sorry about my handwriting, $60. Yay! It was new. It was like the starting point. Analyze tables. It is recommended that a swimming pool be drained at a maximum rate of 720 gallons per hour. Any more than that, and your life is in trouble. The table shows the function relating the volume of water in a pool and the time and hours that the pool has been draining. Actually, you know what? Take a stab at this. You can look at the last one. Yeah. I'm going to put my answer up in 5 seconds. So the x-intercept is 14, 0, because that's where y is 0, so you just have to pull it from the graph. The y-intercept is 0, 10,080, kind of the same reasoning there. And then the 0 we know is when the y value is also 0, and it's when you're at the end of your graph usually. So the y-intercept shows the pool at the start, while the x-intercept shows when it is totally drained. Use the table to determine the x, y, intercepts, and zeros of the graph. Same deal here, make this an oleo, it's just slightly different. And again, if you dislike the presentation of the graph, rearrange it horizontally if it'll make you happier. My answer will be up in just a moment. So here I have set the table up differently, writing the x-intercepts where the y is 0, the y-intercept where x is 0, and then summarizing it as x is negative 2. Now I wrote 14, 0 for this one. That's fine. It's probably a little bit more common to talk about x equals 14 like that. So if you want to go and make that change, you can. That way it'll match what I did in the previous problem too. So hopefully these word problems didn't feel too crazy. And this is a lengthy assignment where you're doing a ton of different work, but it'll definitely be broken up and chunked into multiple assignments.